because we're multiplying and dividing, well, because we're multiplying, we're going to have a common ratio this time. What was it called in the arithmetic sequence, Amy?
Common.
Look, I'm just picking on you because you were chatting. I'm sorry. That's not very kind of me. What was it?
Common difference.
Common difference, right? So when we're talking about multiplying, we're going to be using a ratio. Guess what letter we're going to use for ratio?
R.
Look at you guys. Super smart. Super smart. Okay, the common ratio can be found. Okay, if I want to find the common ratio, I'm going to take a term and I'm going to divide it by the term before it. So I'm going to take 48 and I'm going to divide it by the term before it.
My guess is
48 divided by 24 is 6? I don't think so. 48 divided by 24 should give you 2, right? That's how you can calculate what the common ratio is. This is going to be helpful when you're dealing with like decimals or fractions or things like that. So you take a term and you divide it by the term before it. This is why we can never use the first term, because there's no term before it. So you can't use the first term, you can use any other terms, but you can't start with the first term. Okay, geometric sequence. I'm going to throw some brackets around it. On the formula sheet, it doesn't look like that. I'm going to put some brackets around that r to the exponent. What happens first? Exponents or multiplying? Exponents. So just like in that cosine law that we did, what has the stronger hold? This has the stronger hold. You have to deal with your exponents first. You know what I see people do all the time? This makes me sad. Let's say this is 3 to the 2. I see people do this. And a part of me dies. Part of me dies on the inside. Because that is bad, oh bad. We never do that. We would evaluate the exponent first. And 36 and 18 are two very, very different numbers. Okay, so let's define these. Tn. I say the value of the last term or the desired term we're looking for. So it's the one we're going to stop at. T1 is the value of the first term. What did I say R was?
common ratio.
Common ratio. The thing you're multiplying by. And the N? Number of terms. So really, this isn't that different from arithmetic. It's a different formula, and we're multiplying things. Okay, look at bacteria. Bacteria reproduces by splitting 2 cells, and then those 2 cells split into 4 cells, and those 4 cells split into 8. So what is my geometric sequence? How many cells do I start with? 2. And then what happens when they split? 4. And then what happens when those 4 split? Okay? Sometimes I find that writing out, like extracting that piece of information from the words, it's much more easy to work in this sequence here. Okay, suppose you have 10 bacteria to begin with. 10 bacteria to begin with. So what's your T1? 10. Good job, everybody. What is your common ratio? 2. And how did you figure that out? You looked at it? 8 divided by 4, that gives you 2. 4 divided by 2 gives you 2. And this is pretty easy, so you could say, like, I just knew that I multiplied everything by 2. That's okay too. You don't have to show me how to do it, but just keep in mind, like when we get to fractions, sometimes that helps. So we want a geometric formula to represent the nth term. This sometimes is also called the general formula. And we talked about that in the arithmetic lesson as well. So there's things we don't know. We don't know what n is. And we don't know what Tn is. So we're just going to create a general formula that has some of the information in it. So we're going to have Tn equals 10 times 2 to the exponent n minus 1. Now, what was the deal with arithmetic? I said I'd only give you half marks. If you just did the substitution, you had to multiply stuff through and solve. With geometric, is there anything else I can do here?
Can you
Do not. That's what we just talked about. That was this bad, oh bad. Do not do that. So this, ladies and gentlemen, is where you leave it. That's it. That's the general formula. When it's an arithmetic formula, you have to do more math. When it's geometric, you stop here because you do not multiply those two together. It's the most common error that is out there. Okay. Photograph is 25 centimeters, the length of a photograph. We want to reduce the size of the picture. So right away, reducing. We're going to be making it smaller, right? The photocopier that you're using can only reduce the size to 67%. Hey, true story. When I go to reduce something on our photocopier, 67% is the number. What is the shortest possible length of the photograph after 5 reductions?
So 65% of 25.
Okay, so we're going to go use 67,
Oh,
right?
yeah.
Yes. Yeah. So what do we know? We know T1 is 25. We know the common ratio is 0.67 because we just converted that percentage into a decimal so we could deal with it. What do we know n is? 5. But we want to do 5 reductions. So where am I going to be? No, hang on. So if T1 is 25, has that been reduced at all?
No.
So T2, you guys would agree, is my first reduction. Yeah? And T3 would be my second. T4 would be my third. T5 would be my fourth. So what term is my 5th reduction?
T6.
T6.
How was I supposed to know that?
Gotta math it out. Count it on your fingers. So what's my n? I'll ask that question again. 6. I'm looking for that right there, the 5th reduction. So I'm looking for n equals 6. Ooh, T6 equals, we don't know. Okay, formula is Tn equals T1 times R n minus 1. Okay, do some math. I'll do some math, you do some math, it'll be great. Hopefully it's a small number.
Like a small big number.
A small big number. How many places do you guys want to round to?
2.
2, 3? What do we want?
2.
I like 2. All right. I didn't show my step of taking 6 minus 1, but I figure it's something we're pretty confident we do. Can n ever be a decimal?
Yeah, I guess.
What does n represent?
Change no decimal.
What does n represent?
Like,
The number of terms or the current term. So n represents number of terms. Am I going to find half a term? No. So we can expect n to always be a natural number. And why do I say natural and not whole? What does whole have that natural doesn't? 0, right? And we'd never have term 0. So it's got to be a natural number. The more you talk about numbers, the more likely you are to remember them. Especially number families. Okay, this one's a thinker. This one's a thinker question.
aren't they all?
It's not hard math, but it is a little bit of a thinker question. Okay, we know the third term is 54. We know the sixth term is negative 1,458. Determine the value of T1, R, and list the first 3 terms of the sequence. Okay. Wow. It's not a lot to go on there. But when you get yourself into a situation like this, what do we know about the common ratio? It's the same. No, you're going to multiply by that same thing no matter where you are in the sequence, no matter where you are in the set of numbers. So what you can do is you can make a fake set. What if you treated this as just your set of numbers and used this as T1? How many terms would I have? 4. I know term fake 4. I know term fake 1. The only thing I'm missing is the R, and as soon as I find the common ratio, I can then go back and find real term 1 and real term 2. Makes sense? So we're going to have some fake, and then we're going to have some real stuff. So I'm going to use this as a fake set of numbers. Not fake, just this is a fake term 1. But I have important information here. So my fake T1 is 54. My fake T4 is negative 1,458. My n is 4.
Why is it 4?
1,
Oh,
2,
yeah, yeah.
3,
I was
4.
thinking about common difference.
Right. And what we're going to try to find is R. Because once we have the common ratio, that can be applied forwards, backwards. We've got a lot to work with then. Okay, so we have negative 1,458. Guys, what do you know about your common ratio? If one number is positive and one number is negative, what do you know about your common ratio? Has to be negative. Okay, so all I have is one variable left to solve for, and I'm a smart person, I can do this. You guys are smart people, you can do this. Now remember that this is a stronger bond than that multiply there. So I have to keep this together. So I'm going to divide each side by 54. put an equal sign in there? It's gonna cause me problems. So I get a negative 27. And I equals r cubed. How do I get r by itself? Cube root it. You probably don't need your calculator for this. 3. What kind of 3? A negative 3. Okay, so now we're gonna get to our real information. We're gonna go away from the fake. We know that going this way, we're gonna have to times by a negative 3. Right? So we would take 54. 54 times negative 3 gives me negative 162. Times by a negative 3 gives me 486. But the question didn't ask me for the fourth and fifth term. It asked me for term 1, term 2, term 3. So if going forward is multiplying, to go backwards, what am I doing? Dividing. So if I have to go backwards here, I'm going to divide by negative 3. So 54 divided by a negative 3 is a negative 18. And oh, I can do that one in my head. I'm going to get a positive 6. Wow. You will get one of these questions on your test for sure. Okay? So you just got to remember to take the fake set and do some math with that. Super exciting. I know you're super excited. Okay, this one has to do with the piano. It's confusing. Do some of you play the piano in here? Yeah? Okay, good. Okay, I don't. So this is the best we're gonna get. Piano has 88 keys. There we go. Key 1 has a frequency of 27.5, and the 88th key has a frequency of 4,186.009 hertz. Okay, these frequencies follow an approximate geometric sequence. Calculate the common ratio between the first and the fourth key. How do we find the common ratio? So you guys know first key is 27.5. We know the fourth key is 32.7. Isn't this exactly what we did in the last question? Yeah. Okay, so we know that Tn is, well, it's T4, is 32.7. We know T1 is 27.5. We know N is 4, and we're trying to find the common ratio. Okay, go forth and do the math. Okay, so if you did the math, you 1.0594. I'm using them all just for, we didn't talk about rounding, so easy peasy. Okay, now what I want you to do is use the highest and lowest frequencies. So the first key and the 88th key to verify our common ratio. The idea is that they should be exactly the same. The common ratio doesn't change based on what numbers you're looking at. It's going to be the same for both of them. But we know things are going to change a little bit. T1 is still going to be the 27.5, but now we're dealing with T88, which is 4,186.009. So what's my N? 88. Okay, do the math.
Did you just guess 4,186.009?
Yeah.
Smart. Do the math.
So to do this, what do we look at which series number?
Well, you know T1, because that's, you know Tn, you know what you end with, right? So you know Tn, sorry, on the first day he places 5 cents in the jar. So you know D. So is this a series or is this a sequence question? Because I want to know. Right. Okay. Did you guys get the same common ratio? Yeah? I hope so.